Okay, we're continuing to solve integrals using trigonometric substitution. Okay, so when we have an integral, what we're looking for is an expression of the form x squared plus or minus a squared, or a squared plus or minus x squared. Either an expression that's in that form or an expression that we can put into that form using like factoring, for example. Or maybe you could make a substitution. So if you had 25 minus x plus 1 squared, you could say that u is equal to x plus 1. So then you have 25 minus u squared, and you could get it into that form that way. So like we could do a trig substitution with an expression like this. Okay, so these are the three scenarios where you would use a trig substitution. And all this is just different ways of arranging the a squared and the x squared. So a squared minus x squared plus x squared minus a squared. And they've got this under a square root because that's the most common scenario when you're going to do a trig substitution, would be under a square root. The trig substitution is powerful. It ends up eliminating the square root. But technically, we're really just talking about we're referring to the a squared and the x squared combination. That's what we're substituting for. So we're going to do problems where you might have like a squared plus x squared squared, for example. Well, that still applies to a trig substitution. Okay. So when you have an integral, the first thing you'll look for is maybe you could just do a u substitution. A u substitution would be quicker and easier than a trig substitution, but here we could perhaps say u is equal to x squared minus 9, but then that wouldn't work. So we're going to do a trig substitution to solve this. And so we identify here's a x squared minus 3 squared. And so if we come to the chart, that's this form here. And so we want to substitute x is equal to a secant theta, where a in this case is 3. So we're going to say that x is equal to 3 secant theta. Okay, so dx d theta is 3 secant theta tangent theta. Therefore, dx is equal to 3 secant theta tangent theta d theta. All right, and so what's the purpose of this? Well, if we substitute this into the square root of x squared minus 9, so x is equal to 3 secant theta, so we've got 9 secant squared theta minus 9. We've got secant squared theta minus 1. And so we can see that secant squared theta minus 1 is equal to tangent squared theta. And so this is going to be 3 tangent theta. Now, normally we would have to say that this is the absolute value of tangent theta because, if you input certain thetas, tangent theta is negative, right? Well, there's no negative coming out of this. You've got tangent squared theta. Well, it's squared, first of all, but then you have a principal root. But we can leave this off because when doing these trig substitutions, we have to make sure that the trig function is 1-to-1. So we have to restrict the domain of theta in the trig substitution. And so, it's kind of like the similar idea to how inverse trig functions are set up. And so here, the theta is restricted to 0 to pi over 2 or pi to 3 pi over 2. And in those intervals, tangent theta is always positive. So we just have 3 tangent theta. And so there you go. You see, so with this substitution, we've gotten rid of the square root, and it's just this simple single trig function. All right. So now, making the substitution, x cubed. So what is 3 secant theta cubed? That's 3 cubed is 27. and then secant cubed theta. Okay, and then 3 tangent theta. Okay, dx, 3 secant theta, tangent theta, d theta. Okay. So, okay, this is 3 cubed, so, okay, now there's a squared. Okay, so tangent squared theta over secant squared theta d theta. Oh, and then we have a 3. So we can take out a 1/3. Okay, so, I see this secant squared theta in the denominator, and I know we can turn this tangent squared theta into, I think it's secant squared theta minus 1. And so, but with a single term in the denominator, we could separate this into separate integrals. So to me, let's go ahead and do that. Right, now we can do 2 separate integrals. And so let's do that. All right, so secant squared theta divided by secant squared theta. Okay. And then secant 1 over secant squared theta is cosine squared theta. Okay. So we've got theta over 3. And then, okay, we can solve any power of just a cosine or sine by itself. We need to use the half angle identity. That's what we learned in the previous section. So cosine squared theta is 1/2, and then 1 plus cosine 2 theta. So one-sixth, and then, all right, so d theta minus 1/6, and then, okay, so 1/3 theta minus 1/6 theta, and then the integral of cosine 2 theta is 1/2 sine 2 theta. So 1/12 sine 2 theta. Okay, 1/3 minus 1/6 is 1/6. Okay, now sine 2 theta is equal to 2 sine theta cosine theta. That's a trig identity, right? So sine 2 theta is equal to 2 sine theta cosine theta. So we've got 1/6 sine theta cosine theta. All right, so this is 1/6 theta minus sine theta cosine theta plus c. There we go. But we're not done, though, because we need to put this in terms of x. So how do we do this? Well, we come back here to our original substitution definition. Okay, and so we need to, when it comes to, if we just have just a theta, or just like this variable, then all we're doing is just solving for that variable. So you've got secant theta is equal to x divided by 3. So theta is equal to inverse secant x divided by 3. And that's going to go here. So we'll have 1/6 Okay, but now what about these? What we do there is we construct a right triangle. And this is theta, and we just put the theta in the positive direction. It doesn't matter. And then we come to our definition. And so we've got secant theta is equal to x over 3. So what does secant mean? Secant is inverse cosine. So cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. This is hypotenuse over adjacent. Okay. Now we need to get what is this side? Well, if we say this is z, then we've got 3 squared plus z squared is equal to x squared. So this is square root of x squared minus 9. And so now we can say, what is sine theta times cosine theta? So sine theta, cosine theta. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And there you go. So minus and let's go ahead and distribute this 1/6. I think it'll be better that way. Cleaner that way. So yeah, so there we go. Okay, so we're going to have to do this in terms of a, but that's no problem. And so we can't do like a u substitution, like we could say maybe u is equal to a squared minus x squared, but that won't work. So, but we've got this a squared minus x squared. So what form is that? That's this form here. So we want to make the substitution that x is equal to a sine theta. Therefore, dx is equal to a cosine theta d theta. And so a squared minus x squared, the square root of a squared minus x squared is a squared minus a squared sine squared theta, which is a squared 1 minus sine squared theta, which is a squared cosine squared theta, which is a cosine theta. And we don't have to put the absolute value because the domain makes it restricts it to where cosine theta is always positive, the domain of theta. This domain restriction here, theta is equal to from minus pi over 2 to pi over 2. Okay, so all right, when theta is equal to 0, x is equal, or no, okay, so we're going to update the limits of integration. So we say when x is equal to 0, what is theta equal to? So inverse sine 0. When theta, or when x is equal to 0, theta is equal to 0. When x is equal to a, we have sine theta is equal to 1. So pi over 2. Okay, x squared is a squared sine squared theta. And then square root of a squared minus x squared is a cosine theta. And then dx is a cosine theta d theta. All right, so a to the fourth sine squared theta cosine squared theta d theta. Okay, so we need to use the half angle identities here. So we've got a to the fourth, and then sine squared of theta is 1/2 1 minus cosine 2 theta, and then cosine squared of theta is 1/2 1 plus cosine 2 theta. Okay, so we could take out a 1/4, and then we're left with 1 minus cosine 2 theta times 1 plus cosine of 2 theta. So that's 1 plus cosine 2 theta minus cosine 2 theta, and then minus cosine squared 2 theta. Okay, so we've got we could do 0 pi over 2 d theta minus like that. And so we can use that same double angle identity again, or half angle identity, whatever it's called. Okay, so we have this is just going to be pi over 2, right? Because this is theta evaluated from 0 to pi over 2, so this is just pi over 2. Okay. Cosine squared of 2 theta is, okay, so the identity is cosine squared of theta is equal to 1/2 1 plus cosine 2 theta. And so in this case, we would have 1/2 1 plus cosine 4 theta. Right? So we have and then like that. And so let's see, pi over 2 minus, and then this is going to be pi over 4, because this is equal to pi over 2 times 1/2. Okay, now the integral of cosine 4 theta is 1/4 sine 4 theta. So we could take out a 1/4, and then we're just evaluating sine 4 theta from 0 to pi over 2. Okay. Okay, so sine of 4 times 0, it's 0. So what is sine of 4 pi divided by 2? So sine of 2 pi is 0. So we got 1/2 minus 1/4 is 1/4. So 1/16 pi a to the 4th. And that's it. And what's nice about definite integrals is that we don't have to worry about coming back and substituting to get the function of x, right? It's when we updated the limits of integration based on the substitution, then we were good to go. Okay, so just looking at this, one thing I noticed is we could do a u substitution. So if we said u is equal to x squared minus 7, then du is equal to 2x dx. So 1/2 du is equal to x dx. And so we get right? And so in general, that's how you would solve this. I mean, that's quick. I mean, I can finish this off here. So this is u to the minus 1/2 power. So minus 1/2 plus 1 is 1/2. So root u. Right, so that's the quickest way to solve this. And so in general, that's how you would solve it. But we want to practice trig substitutions. So we identify an x squared minus a squared here. That takes on this form. So we've got x squared minus root 7 squared. So we want to substitute x is equal to root 7 secant theta. Therefore, dx is equal to root 7 secant theta tangent theta d theta. Okay, so seven secant squared theta minus 7 okay, so 7 okay, so we've got and then dx okay, so we can take out a root 7 and then this cancels and we're left with secant squared theta d theta. And secant squared is easy. The integral, that's just tangent theta plus c. Okay, so now we want to make a right triangle. Okay. And so we've got secant theta is equal to x over root 7. Secant theta is inverse cosine. So cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. Okay, so if this is z, we've got root 7 squared plus z squared is equal to x squared. So z is equal to the square root of x squared minus 7. Okay, so therefore tangent theta is equal to opposite over adjacent. So now plugging this in, the root 7s cancel. And there we go. Okay. Now obviously, u substitution was much faster and easier, but still, this is helpful to go through this to learn the process. Okay, here it might look like we could use a u substitution, because if you say u is equal to 1 plus x squared, then du is equal to 2x dx. But this is x to the minus 1 dx on the outside. So we can't use a u substitution, but we see that we've got a 1 squared plus x squared. Therefore, we come here, and we can simplify this with a trig substitution of x is equal to 1 tangent theta. So x is equal to tangent theta. Therefore, dx is equal to secant squared theta d theta. Okay, so we've got 1 plus tangent squared theta, 1 plus tangent squared theta is secant squared theta. And then we could just, we don't have to put absolute value, we can just put secant theta. Okay, so we've got tangent theta, secant theta, and then dx is tangent theta. Or no, dx is secant squared theta d theta. Okay, so now we have an odd power on the tangent, and so if we were multiplying secant cubed theta by tangent theta, then we could separate out a secant theta tangent theta and then say u is equal to secant theta. But this is different because the tangent theta is in the denominator. So since we have just a single term in the denominator, like what we can do is, if we had the secant cubed in the denominator, then we couldn't do this. This wouldn't work as well. But since we have the secant cubed in the numerator, we can say, so secant squared is 1 plus tangent squared theta, and then secant theta okay, so we've got secant theta plus so and then right? So this integral is secant theta, right? So we've got, well, all right, we're going to need to simplify this here. So secant theta is 1 over cosine theta. Tangent theta is sine theta over cosine theta. But tangent's in the denominator. Okay, plus, and then this is secant theta. Okay, so we've got 1 over sine theta is cosecant theta. Okay, in the textbook, we can look this up in the table of integrals in the textbook. This is natural log of the integral of cosecant theta is natural log of the absolute value of cosecant theta minus cotangent theta, and then plus c. Okay. So x over 1 is equal to tangent theta. So tangent theta is opposite over adjacent. So, all right, now the hypotenuse squared is equal to 1 squared plus x squared. So There's the triangle. All right, cosecant theta. So cosecant is 1 over sine. So hypotenuse over opposite. Cotangent theta is equal to adjacent over opposite. And then secant theta is equal to hypotenuse over adjacent. Okay. So we've got okay. So okay. All right, so this is a good example of how to do a trig substitution. You might not explicitly see an expression in the form that a squared plus or minus x squared plus or minus a squared form, but you might be able to take an expression and put it into that form. And so if we look at this integral, so okay, we think, well, maybe we could make a u substitution. So then du is 2x plus 2 dx, and so this isn't going to work, right? So how can we solve this? I mean, this is a hard integral to solve. Well, what we can do is we can use completing the square to put this into a form that we can use a trig substitution with. So what we're going to do is we have x squared plus 2x plus, leave a space. Okay, now we want to make this a perfect square trinomial. We want to put a term here that makes this a perfect square trinomial. So if we've got x plus a squared, then that expands to x squared plus 2ax plus a squared. So in this case, 2a is equal to 2, so a is equal to 1. So we put a 1 here, but then we subtract a 1 here. Right? So now we haven't changed the expression. You see? But this here is x plus 1, because a is 1, squared. Okay, so what we've got is okay, but still though, I mean, this isn't quite in the trig substitution form, but what we can now do is say that u is equal to x plus 1, therefore u squared, this is equal to u squared plus 4. And so now this is in the trig substitution form, and this is we have variable, it's this here. This is a squared plus x squared or x squared plus a squared, where a is equal to 2. So we want to substitute x, well, in this case, x is u. So we want to say that u is equal to 2 tangent theta. So we want to say that u is equal to 2 tangent theta. Okay, but u is equal to x plus 1. So x is equal to 2 tangent theta minus 1. And there you go. This is the trig substitution we need to make. X is equal to 2 tangent theta minus 1. All right, so therefore dx is equal to 2 secant squared theta d theta. All right, so I'm going to go ahead and plug it into the original formula just to, it'll be cool to see how if we just plug this straight into the original formula, it's going to simplify. So let's do that. So x squared plus 2x plus 5. Okay, so 2 tangent theta minus 1 squared, 4 tangent squared theta minus 2 tangent theta minus 2 tangent theta minus 1 times minus 1 is 1 plus 2x, so 4 tangent theta minus 2 plus 5. All right. So 4 tangent squared theta minus 4 tangent theta plus 4 tangent theta. Okay, and then plus 1 minus 2 is minus 1. Minus 1 plus 5 is 4. Okay, so this is 4. All right. Tangent squared theta plus 1 is secant squared theta. So 2 secant theta, and we don't have to put the absolute value because of the domain restriction. Pretty cool, right? So we've got 2 secant theta, and then dx is 2 secant squared theta, and then d theta. So we're left with secant theta d theta. And the textbook gives us this integral, natural log of the absolute value of secant theta plus tangent theta. Okay, but we're not done because we need to put this in terms of x. So we draw the right triangle with a, put theta here, and it's a positive theta, but it doesn't matter. It wouldn't matter if you, what direction you put theta. All right. And so this is a little bit trickier in this case because, okay, we come back here and we want to solve for, so, all right, we've got 2 tangent theta is equal to x plus 1. So tangent theta is equal to x plus 1 divided by 2. Tangent theta is opposite over adjacent. So this is x plus 1, and this is 2. All right, so what's the hypotenuse? Well, if the hypotenuse is z, then it's 2 squared plus x plus 1 squared is equal to z squared. So z squared is equal to, x plus 1 squared is x squared plus 2x plus 1, and then 2 squared is 4. So x squared plus 2x plus 5. So z okay, x squared plus 2x plus 5 square root. Okay. So secant theta is equal to, secant is the opposite of cosine. Cosine is adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. Tangent theta is we just wrote that out over there. Okay, so this is equal to natural log of the absolute value of, and so we have the same denominator in both, so x squared plus 2x plus 5 plus x plus 1, like that. And what we can do is, so this is equal to the natural log of the absolute value of x squared plus 2x plus 5, the square root of x squared plus 5, minus natural log of the absolute value of 2, so natural log of 2 plus c, but this is just a constant. So and there we go. That is the integral. Okay, so if we think, okay, can we do a u substitution? But we see that's not going to work. But it's the same idea. We don't see an a squared plus or minus x squared or x squared plus or minus a squared, but we see an expression that we could potentially put into that form, in particular with the square root on top. And so let's see what we can do here. All right, so this is a little confusing because we've got the minus x squared, but we should still be okay. So minus x squared plus 2x plus, and then we'll leave a gap. Okay, so, yeah, well, you can't, okay, yeah, you can't do there's no such thing as a perfect square trinomial with a minus coefficient out front like that. So, okay, let's factor out a minus. Let's see what this does. Oh, no, this would be minus 3. Okay, so x plus a squared is x squared plus 2ax plus a squared. So here 2a is minus 2, a is minus 1. So that means this would be a 1. So that we don't change the equation, we'd need to put minus 1, like that. And so this is x squared minus 2x plus 1 minus 4. So this is, so minus, then we've got x minus 1 squared minus 4. Is that right? So x squared minus 2x plus 1 minus 4. That's x squared. Let me check this. So x squared minus 2x plus 1 minus 4 is x squared minus 2x minus 3. Now you put the minus sign in, and that's, yeah, that's right. Okay. So, okay, but now what we're going to do is we're going to put the minus sign in, and we'll get 4 minus, there we go. So yeah, we can work with this. So this is, okay, so if we say that u is equal to x minus 1, then we've got 4 minus u squared. And that means the trig substitution we want to use is this. So we want to say that u is equal to 2 sine theta. U is equal to 2 sine theta. Therefore, x minus 1 is equal to 2 sine theta. X is equal to 2 sine theta plus 1. That's the substitution. So x is equal to 2 sine theta plus 1. Therefore, dx is equal to 2 cosine theta d theta. Okay, so 3 plus 2x, the square root of 3 plus 2x minus x squared is equal to 3 plus 4 sine theta plus 2 minus x squared is 4 sine squared theta plus 4 sine theta plus 1. So 3 plus 4 sine theta plus 2 minus 4 sine squared theta minus 4 sine theta minus 1. Okay, these cancel. And we got 3. Well, okay. 3, 4, 5. 5 minus 1 is 4. So 4 minus 4 sine squared theta. So factor out of 4. One minus sine squared theta is cosine squared theta. And we've got 2 cosine theta. Okay. So x squared is, we've got 2 sine theta plus 1 squared, 2 cosine theta, and then dx is 2 cosine theta d theta. So we've got 2 sine theta plus 1 squared is 4 sine squared theta plus 4 sine theta plus 1, and then 4 cosine squared theta d theta. All right, so we've got 16 sine squared theta cosine squared theta plus 16 sine theta cosine squared theta plus 4 cosine squared theta d theta. Okay, so let's solve each of these separately. So this integral here, we've got 16 sine squared theta cosine squared theta d theta. And in this situation, we need to use the half angle identities because the powers are even. Both powers are even. And so we've got, so 1/2 1 minus cosine 2 theta, and then 1/2 1 plus cosine 2 theta. Okay, so taking out 1/4, we have 16 divided by 4 is 4. Okay, 1 minus cosine 2 theta times 1 plus cosine 2 theta is, it's going to be 1 minus cosine squared of 2 theta. Okay, so we've got 4 d theta minus 4 cosine squared 2 theta d theta. So we've got 4 theta, and then here we want to use the half angle identity again. So we're going to have 1/2. So let's bring the 1/2 out, and then 1 plus cosine 4 theta, right? Because we're doing this with cosine squared 2 theta. Okay, so we've got 4 theta minus 2 d theta minus 2 cosine 4 theta d theta. Okay, 4 theta minus 2 theta minus, all right, the integral of cosine 4 theta is 1/4 sine 4 theta. So this is going to be 1/2 sine 4 theta. So 2 theta minus 1/2 sine 4 theta. Okay, so let's write this out in to separate integrals here. So sine squared theta cosine. Okay, so this is equal to, we have 2 theta minus 1/2 sine 4 theta. Okay, now okay, so now let's do this integral. We've got 16 sine theta cosine squared theta d theta. So here we can say that u is equal to cosine theta. Therefore, du is minus sine theta d theta. So we've got, take out the minus 1, and we've got u squared du. Minus 16 times 1/3 u squared. Minus 16 thirds, or no, u cubed. Minus 16 thirds cosine cubed theta. Okay. Minus 16 thirds cosine cubed theta. Okay, now what is the integral of, was 4 times the integral of cosine squared theta d theta. This is, so 1/2. Let's bring out the 1/2. 1 plus cosine 2 theta d theta. So 2 d theta plus 2 cosine 2 theta d theta. 2 theta plus integral of cosine 2 theta is 1/2 sine 2 theta. So this is just going to be sine 2 theta. Okay, plus 2 theta plus sine 2 theta. Okay, so 2 theta plus 2 theta is 4 theta. Then minus 1/2 sine 4 theta plus sine 2 theta minus 16 thirds cosine cubed theta plus c. Okay, now we can use the trig identity that sine 2 theta is equal to 2 sine theta cosine theta. Okay, now, so with sine of 4 theta, if we say that u is equal to 2 theta, then sine of 4 theta is sine of 2u, which is 2 sine u cosine u. So sine of 4 theta is 2 sine of 2 theta cosine of 2 theta. Okay, so sine of 4 theta is equal to 2 times 2 sine theta cosine theta. And let's just leave this as cosine 2 theta for now. Okay, so we've got 4 theta minus 1/2. And then we could take out that 2, so we just have minus 2 sine theta cosine 2 theta. And then plus 2 sine theta cosine theta minus 16/3 cosine cubed theta. And then we'll bring the plus c on in a second. Let's just omit this for now. Okay, so we've got 4 theta plus, and then, okay, 2 sine theta cosine theta. And then that's 1 minus cosine 2 theta minus 16/3 cosine cubed theta. Okay, now 1 minus cosine 2 theta is equal to 2 sine squared theta. So this is 4 sine cubed theta cosine theta. Plus c. Or this is 4. There we go. Okay, so now we just need to make this a function of x. So let's draw the right triangle. Okay, so 2 sine theta is equal to x minus 1. Sine theta is x minus 1 divided by 2. So sine theta is equal to opposite over hypotenuse. Okay, if this side is z, then you've got z squared plus x minus 1 squared is equal to 2 squared. So z squared is equal to 4 minus x minus 1 squared. Z squared is equal to 4 minus x squared minus 2x plus 1. Z squared is equal to 4 minus x squared plus 2x minus 1. Z squared is equal to minus x squared plus 2x plus 3. So z is equal to the square root of 3 plus 2x minus x squared. Okay. And so sine theta is equal to x minus 1 divided by 2. Cosine theta is equal to adjacent over hypotenuse. Okay, and then theta is equal to that. So, all right, so we've got 4 plus 4 times, so okay, 2 cubed is 8. So 4 divided by 8, so we're going to have x minus 1 cubed over 2. Okay, now times cosine theta. And so we'll have x minus 1 cubed and then 3 plus 2x all over 4. Okay, minus now 16 thirds times cosine cubed. This is going to be an 8, so we'll have a 2 thirds out front. Okay, and then this cubed. So 3 plus 2x minus x squared. That's to the 1/2 cubed, so to the 3/2, and then plus c. And this is the integral.